This video is for topic 7.6, properties of the equilibrium constant. The objective for this topic is to represent a multi-step process with an overall equilibrium expression using the constituent K expressions for each individual reaction. So we're going to look at what happens if you multiply a reaction by a coefficient, what happens if you reverse a reaction, and what happens if you add multiple reactions together to form a net reaction. So first, if you need to multiply all of the coefficients by some factor, the new K, whether it's the expression or the equilibrium constant, is raised to the power of that multiplication factor. So in our example reaction, we have carbon reacting with half mole of oxygen to produce carbon monoxide. Our original K, it would be CO divided by O2 raised to the 1/2 power, which is 4.6 times 10 to the negative 23rd. If we multiply all of our coefficients by 2, so our factor is 2, our new K would be our original K raised to the 2nd power, or squared. So that goes for both our equilibrium expression. So we'd have CO squared divided by O2, which when we plug in our constant is 4.6 times 10 to the negative 23rd squared, which gets you 2.1 times 10 to the 47th. When you reverse a reaction, you're going to take the reciprocal of the K value because your products are now your reactants and your reactants are now your products. So we have an acid reaction here. So we have an acid reacting with water to form the conjugate base and the hydronium ion. And so when we do products divided by reactants, we don't include our water. So we end up with 1.8 times 10 to the negative 4th. When you reverse the reaction, since your reactants are now your products and your products are now your reactants, we have to take the reciprocal of our K value. So we swap what's on top and what's on bottom. And so you can do 1 divided by your original K, which in this case would be 1 divided by 1.8 times 10 to the negative 4th, which gets you 5.6 times 10 to the 3rd. And finally, if you add 2 or more chemical equations to create a net equation, the equilibrium constant is the product of the equilibrium constants for the added equations. So let's look at our example. So we have 2 reactions here, and we're going to combine them to form a net reaction, which is below the dotted line. Our first reaction just includes the products because the reactant is a solid. So it's going to be the silver ion multiplied by the chloride ion, which has a constant value of 1.8 times 10 to the negative 10th. And our second equilibrium expression has our product divided by our 2 reactants, which one of our reactants is squared because it has a coefficient of 2, just like normal. And so that K has a value of 1.1 times 10 to the 7th. Now, when we add those 2 reactions together to get an overall net reaction, we multiply our 2 K values. So if you multiply the 2 K expressions, you end up with the K expression for the net reaction. And then you can plug in the 2 different K values. So K1 times K2, which gets you 2.0 times 10 to the negative 3rd. So you can do any combination of these. You just have to remember when you're combining reactions, what you have to do to the K values to represent what you're changing for the reaction. So if you're multiplying all of the coefficients by a factor, you have to raise the K value to that factor. If you reverse a reaction, it's the inverse of the K, inverse of the constant. And if you're adding multiple reactions together, you have to multiply all of those K values together to get your overall equilibrium constant for your net reaction.